Hi everyone, today we're going to talk about some two-column proof examples to try to help you out with some of these topics because I know that two-column proof can be a difficult one to understand because it's the first time you've ever seen anything like this. So let's go through a couple examples together that show different aspects of the two-column proof. The first example, you're given a triangle and they tell you that side AB is equal to side CB. So you can go ahead and put that right on your triangle as soon as they tell you something. And line BD, so that means there's a line going down from B to D. It says that that bisects angle ABC. So if it bisects it, angle ABC is there. So if you bisect that angle, that means that that part is going to be equal to that part. And you can put that right on your diagram. And you want to prove that this triangle is congruent to this one. So anytime we're asked to prove something, we set up a two-column proof. It's the easiest way to keep everything organized. And the thing with the two-column proof is you have to make sure that all your steps are logical. You can't go and say something is the way it is just because it looks that way. You have to logically prove it and show all the information. So you've got a statement and a reason. So the first things we put down are the given things. So AB is equal to CB, and the reason, it was given to us. We don't have to prove it, they told us it was. BD bisects angle ABC, so I'm going to, the way I write that is angle ABD is equal to angle CBD because of the bisector. It cuts the angle in half. So we know that ABD is equal to CBD. So now we have to prove the congruency. So to prove congruency, we want something like side, 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 angle, side, all those things that we talked about in previous grades about what makes two triangles congruent. So that's what we're looking for. And right now, we have a side and we have an angle. So it would be kind of nice if we could get another angle or another side. And we can do either. I'm going to go for side. Side BD, B to D, is the same in triangle A as it is in triangle C because it's a shared side. So BD is equal to side BD. And it sounds silly to say that, but we're only saying that because we have to write down absolutely every step in a proof. So we're saying that side BD in triangle A is the same as side BD in triangle B, and we call that the reflexive, I spelled that wrong, sorry. The reflective property. So now we have a side, an angle equal in each one, and we have another side that's equal in each one. So we've got triangle ABD is congruent to triangle CBD. And the order of these letters is important because the corners have to match up. Corner A has to match with corner C because of the first ones that you wrote. B with B, D with D. So the order matters. And that is, are they congruent because of SAS. So that's how you would prove this one. It only takes 4 steps, but you have to write down absolutely everything along the way. Let's look at another example. And this one is a little bit different because you've got numbers inside the angles. And let's call these, let's give it some letter points as well. A, B, C, D, E, and F. All right, so A, C, D. A, C to D. So that encompasses angle 1 and angle 2 together. Is the same as angle C to D to F. So those two angles are equal to each other. We don't know if they're 90 degrees. They might look like they're 90 degrees, but we have no proof yet. So we can't say they're 90 degrees, but we can say that those two angles are equal to each other because it was given to us. We also know that angle 1 is equal to angle 4. So I'm just putting equal symbols in there. I'm going to set up my two-column proof with a statement and a reason. And I'm going to say angle ACD is equal to angle CDF given. And angle 1 is equal to angle 4 given. So the first things in your proof are pretty easy to do because they are given to you right up at the beginning of your question. You don't have to think about them. They're right there. So this proof is a little more complicated than the other one. We're going to use this statement right here to create another statement. ACD is this angle, this green angle up here, and it's made up of two parts. So I can say that angle 1 plus angle 2, and then I'm going to look at the second angle here, CDF, this green one down here. It's made up of two parts. It's equal to angle 3 plus angle 4, and that's transitive. The transitive property just means you're saying something a different way. So you're saying exactly the same thing as you said before, but you're writing it differently. Now we know that angle 1 is equal to angle 4, and we've got a 1 and we've got a 4 inside this proof, which is great news because it means I can replace. So I can say angle 1 plus angle 2 is equal to angle 3 plus angle 1, or you could have replaced the 4's. Substitution. Of equal parts. And then from there, well, if I've got a 1 on this side and I've got a 1 on this side, you know that you can get rid of those. But that's the same thing as saying 2 plus something is equal to b plus 2. Well, the 2's are the same, so I can subtract those off of both sides, and I end up with this has to equal that in order for this to work. So I can do the same thing here. I can cross those off by subtracting them, and I can say that angle 2 is equal to angle 3 subtraction of equal parts. So now, after all the proof that we've just done, we've just proved that angle 2 is equal to angle 3. Let's take a second to go back up to what we're supposed to be proving. We're supposed to prove that line BC, this one right here, is parallel to line DE. Well, we just proved that angle 2 and angle 3 are the same. And if you remember your angle properties, this creates a Z shape And that is one of the properties that says if the two angles inside the corners of the Z are the same, the alternating angles are equal, then you have two parallel lines. So line BC is parallel to line DE because of alternate equal angles. And we finished the proof. So there are some things like you might have looked at this and said, well, that looks like a right angle and that looks like a right angle and they have to add up to 90. It doesn't have to be a right angle. Maybe this is an 80-degree angle and this is another 80-degree angle, and these two angles in here, they look like they're the same, but maybe they're not. Maybe this one's 42 and this one is 38, and it's really hard to see that with the naked eye that those two angles are different, but they look the same. So you have to go down through the steps, and you can't just say something like, well, it looks like it's equal, so it's equal. You have to prove why it's equal by following logical steps down through. The transitive property is one that you're going to want to remember because you're going to use it a lot, saying something a different way. Substituting and subtracting or adding, it could be adding, are also ones that you're going to use a fair amount. So I hope this has helped you with your understanding of how the two-column proof works. And if you have any more questions, please contact me in the AC room of the course. Thanks and have a great day.